Good morning, everyone, and welcome to day 2 of Epsilon 2021. I am Shruti Singh, Secretary of IEEE SIESGST.
And I am Shruti Tiwari, Technical Head of IEEE SIESGST. Yesterday, we learned a lot about AI, ML, and its applications. We were introduced to its history and solved your doubts about its niche.
And today we are back again with yet another wonderful session for you guys. Today you are going to learn something new and exciting since it's going to be a hands-on workshop.
We hope you're all ready with the required Google Colab and Docker as instructed, fully energized for the upcoming session by our esteemed guest, Ms. Vinita Silaparasetty.
Miss Vinita is a data science instructor, trainer, author, and speaker. She specializes in Python, R, Julia for machine learning as well as deep learning. Her expertise includes using TensorFlow and Keras for neural network model building.
She curates the course materials with great acumen and finesse that made comprehension of analytics easy to understand and apply practically. She's very clear about what she wants to convey to her students and is quite an expert in her field.
Good morning, everyone.
Good morning, ma'am.
Good morning, ma'am.
All right, so I hope everyone's excited to learn about deep learning.
Yes, ma'am. We are so
Yes,
happy
ma'am,
to
very
have you
excited.
here today with us. It is a pleasure to meet you.
Yep, same here.
I'm pretty sure that our audience here is as excited as we are. And we can't wait to get this session get started.
Yeah,
All right.
but before we get started with this workshop, a small reminder for all our attendees here that we have planned another exciting and fun task for all you, so which will be disclosed by the end of the session. Give it your best shot to win your badges and some exciting goodies.
So, without any further delay, we would like to hand over the session to Ms. Vinita and lead the journey for our participants and guide them to the practical world of ML and AI.
Okay, hello, everyone. So, as you already know, I'm Vinita Silaparasetty, and I'll just be sharing my screen with all of you. Okay, I think it should be audible. It should be visible now. Is my screen visible? I just like to know.
Yes, ma'am. You can see.
All right, that's great. So today we're going to work on the classification of the applications. That is, we're going to predict if a person has diabetes or not.
Yes, ma'am.
So, first of all, machine learning it comes under artificial intelligence, and then the advanced version of it is called deep learning. In deep learning, we use neural networks. Today, we're going to get a little taste of what neural networks are like by building a simple DNN, that is, a deep neural network. Here's the workflow of what we're going to do today. First, we're going to start with EDA, data cleaning. This is a very important step. And in the real world, as a data scientist, about 80% of your time is going to be spent here. But today, it's a simple workshop, so we're not going to spend too much time on it. Next, we have model building. After that, we're going to build a Streamlit app so that any user can interact with our model. And finally, we're going to deploy the model and the app on Google Cloud. So I hope all of you have your Google Cloud ready.
Ma'am, I'm extremely sorry that you are rejoin the meeting.
Sure.
Sorry about the glitch. Our audience is here. Our host will join in just some time here. So please wait.
Till that time, you guys can get ready with your Google Cloud and Docker. As soon as ma'am will get back, we can get started with this. Till that time, I would like to ask the audience if they liked yesterday's session. I hope you guys really enjoyed that. Today, let's continue with this session.
Yeah, I love to see all your comments in the chat box. How much excited you are. So guys, the speaker is back and hopefully we'll start soon.
Ma'am, we can continue this session. Our audience is quite excited about this.
All right, so sorry about the echo.
Not an issue, ma'am.
This time, I hope it's better.
Yes, ma'am.
Yes.
Okay, so all I said so far, I hope you understood that deep learning is just an advanced version of machine learning. So that's when you use neural networks. And on your screen, you should see the workflow that I have planned for today.
Yes,
First, we're going to start with EDA. I believe you heard all of that. So let's get straight into the coding. First of all, we're going to import the important libraries. Kindly type in your own notebook what you see on the screen. I'll be explaining the libraries in the meantime. Now, I know everybody has their own pace when it comes to typing, so don't worry. At the end of this conference, you will get a copy of the notebook. For now, just try your best to follow along. So first of all, we have MLXN. This is going to help us with plotting our graphs during EDA. Then, of course, the all-important TensorFlow and Keras. The latest version of TensorFlow, that's TensorFlow 2, is highly dependent on Keras. So these two go together. Then we have keras.models. Sequential. This means that each layer will be in order. It will be executed in order. And then we're going to use dense layers for our current model. This just means that every node will be interconnected. Then we're using NumPy. This is very important for data pre-processing. After that, we have pandas. This library helps us to properly work with our CSV file. And matplotlib is one of the basic plotting libraries. This will help us make visuals. Seaborn has even more features when it comes to visualizations. So this gives us more color options and just gives an overall better effect. Additionally, I added another library called Plotly. This is used for visualization as well. And I thought it would be good practice for you as students to at least get an idea of how it works. Once again, you can see ML Extend. This is for the min-max scale. I'll explain more about scaling as we move forward. And then we have a load model. In fact, this is not needed right now. All we will do in this notebook is save the model. And then you can see sns.set.
Hello, ma'am.
Is it clear, the audio and video?
Yes,
I hope
ma'am.
everything's
Yes.
clear. Okay.
Yes, ma'am.
As I was saying, sns.set, this is for the behind-the-scenes setup of Seaborn. Then import warnings. Now, sometimes TensorFlow does give arbitrary warnings, like future warnings, which won't affect your code, but it wants to let you know that in the future, certain changes are coming up in TensorFlow. We don't need to know about them right now, so that's what the import warnings library is for. And matplotlib inline. This makes sure that our graphs remain within the notebook window and they don't get cut or extend outside the window. So I'm assuming by now everybody has the libraries written down. Maybe I'll just give you a little more time.
Yes, ma'am. We can give our participants bit time so that they can get on with this.
Okay. In the meanwhile, I hope everybody has seen the GitHub link. Because that's where I stored the data, which we're going to use. Kindly let me know when we can move forward, when everybody's ready.
I think we can continue.
Okay, that's great. So now that you have your libraries imported, it's time to load the data. Loading the data is really simple. We're going to use pandas, and we're going to read in a CSV file. You can see the command here, pd.read, and within the brackets, you need to enter the link. Now let me show you how it's done. Head over to GitHub, go to the data folder, and use diabetes.csv. So click that. and go to the raw version. You can see the button raw here. Click that. Then copy the link. And paste it here. I hope that was clear. If anyone has confusions, I could repeat.
If anyone has a doubt, they can ask in the comment section. Ma'am will get back to them. Ma'am, I think you can continue with this.
Okay, cool. So the next command, diabetes_data.head, will just show us the first 5 rows of the data. This gives us a sneak peek at what we're working with. You can see the different columns. I made a little data dictionary here, so I'll explain what each of them are. The data we're working with, although it's called the Pima Donna Indian data set, this refers to the Native Americans, not us Indians. And specifically, it's about the women. This data set is just about women. So it takes into account the pregnancies, that is the number of times they were pregnant. Then their glucose, that's the plasma glucose concentration, in a window of 2 hours. And the blood pressure, this is the diastolic blood pressure, and skin thickness. At the triceps, they tested the thickness of the skin folds. Then the insulin, which is produced by their body in a window of 2 hours, and their body mass index. Then the diabetes pedigree function. This is a function which scores the likelihood of diabetes based on family history. Then, of course, the age and the outcome. This is important to us because this is our target variable. This is what we want to predict. And it has 2 classes. 0, indicating that the person does not have diabetes, or 1, indicating that the person has diabetes. Don't worry, these are all medical terms. So if they sound a little confusing, you don't need to worry about it. Your model is going to take care of all these features. Let's move on to the first step, that's descriptive statistics. Anytime you get a new data set, you're going to do descriptive statistics to understand the data. The first important function is info.info. So as you're typing it in, I will explain. Personally, I find this function very useful because it lets me know the data types. Sometimes, although a data type is of type integer, like when you look at the value, you will see a number there. But it might have been stored as an object, and this will cause problems later on. So what I like to do is convert it. Lucky for us, all the data types look good. They are all integers or floats, which our model can easily work with. Thanks to the info function, we were able to find out that we don't need to change the data types. By the way, changing of data types comes under the data cleaning process. If I'm going too fast or something is not clear, just let the admins and moderators know, and they will tell me accordingly.
Yes, ma'am, sure.
Cool. So shall I move on to the next function?
Yes, ma'am.
Okay. Next, we're going to use what is known as the describe method. This generates descriptive statistics. That will give us the central tendency, dispersion, and the shape of the data set. Now, the reason I put it out here is so that you can understand what each of them are. The count is the number of non-empty rows in a feature. That means there are no NaN values here. It'll just ignore the NaN value and give you the statistics for the rows which have data. Then we get the mean, that's obvious, the statistic mean, and the standard deviation. This we've learned in school, so no need of going through it again. Then the minimum value of the feature. Within that entire column, it gives you the minimum value. Then the 25th percent, 50%, and 75%. This relates to quartiles, and this is important to detect outliers. Lucky for us, we don't have to worry about outliers right now. But in very large data sets, an outlier can cause trouble if it's not handled correctly. And then the maximum value of the feature. So now that you've understood what you're going to be seeing, let's use the actual function. Just type in diabetes underscore data dot describe. So while you're typing, I'll just explain a little more. I personally prefer the describe function to identify the presence of outliers. But as I told you, we don't have to worry about that. So this is to give you practice with how you should tackle your data set when you get it. Shall I move on to the next?
Yes, ma'am.
Okay. Next is another important step. This is seeing the shape of the data set. So kindly type in the function as you see it, diabetes underscore data dot shape. We don't use brackets here because it is not a callable function. You might have noticed that so far we've been using brackets. That's because those are callable functions, but here we don't need the brackets. Once you run the cell, you should get the shape like this. The first section indicates the number of rows, and the second section indicates the number of columns. So we have 768 rows and 9 columns. That was a short section, so I'm sure you're all done by now. I'm going to move on to the next step, which is handling of missing values. First of all, before you can handle missing values, you need to identify them. So we're going to create a copy of our data set. Kindly type in .copy. Deep just indicates that you want to copy the entire data set. This is good practice. That is, copying of the data set is good practice, so that you have one version of the original data as it is, and then you have one version which you can work with however you please. Then in the next step, I selected only the columns that are of particular interest. That is glucose, blood pressure, skin thickness, insulin, and BMI, because we're not too concerned about the rest of the data. This is just preparation for the step after handling missing values, so don't get confused. Okay, I'm assuming you've typed it in by now. So we're going to print out the number of missing values by using the print function, diabetes underscore data underscore copy. We're working with the copy of our data set, .isNow.sum. The isNow function identifies the missing values, and .sum will add them all up so that you can see the total number of missing values. In your output, you should see that glucose has 5 missing values, blood pressure has 35, skin thickness has 227, insulin has 374, and BMI has 11. Now, when you're doing data analysis, usually EDA and data cleaning go hand in hand. The EDA helps you visualize your data, and that's how you identify what data cleaning you need to do. So many people have a debate, do I do EDA or do I do data cleaning? It makes no sense to have that debate because they both go hand in hand. So if you're done with that, we're now going to visualize the missing values. Kindly import the library as I have. The library is called missing.no, and we're going to import it as MSNO. Now, whenever we say as a given name, it's just so that it becomes easier for us to work with the library. And you can name it anything you want. But I found that MSNO is simple enough. Just remember, whatever you name your library, you should use that same name throughout your code whenever you're calling that library. Then you can store it in a variable. I just named it P, but you can name it anything. And use msno.bar. Sorry. To create a bar plot. So the bar plot shows us the percentage of values that are present. And this helps us identify how many values are missing. For example, here about 30% of the values are missing, and so on. So EDA just helps us quickly identify things such as missing values or outliers, depending on what graph you're plotting. I'll move on to the next section. Would anyone like me to pause?
I think the participants are finding it very interesting. So I should continue.
Okay, cool. Now, I'm going to give you another tip here. When I'm working with large data sets, before I even start data cleaning, I like to identify columns which have a high correlation with my target variable so that I know that the column will be of use to me later on. Because if there's a column that's not going to be of use to me, I don't want to waste my time cleaning it and filling it with values. So we're going to use something known as the core method. And particularly, we're going to use Pearson's correlation function. Then we're going to find the maximum value. And it'll return only those columns with a high Pearson value. And we know that these columns are of importance to us. Since this data set has only 9 columns, and each of these columns are very much correlated to our target variable, we're going to work with all the columns. But in a large data set, this would help you identify which columns you can drop. Now, from an EDA perspective, we're going to plot a heat map. Once again, using Pearson's correlation function. And this will give us a visual of which features have a high correlation or not. According to the scale, values which are close to 0.8 or 1, remember these are percentages, so actually this indicates 100, this indicates 80, this indicates 60, and so on. So the higher the value, the better the correlation. The lower the value, the lower the correlation. And this heat map shows the correlation of each feature with the other. So at this point here, we're looking at the correlation of pregnancies with glucose. I hope that's clear. Right, so I'll explain a little more about this line here. First of all, we're using SNS, that means seaborne. And here, anot equals true. This means we're saying that we want the values to be displayed within our heat map. CMAP is a range of color options that are available to us. I decided to go with purple and blue just to match the theme of Epsilon. And figure size. This is helpful when we want to specify the size of the figure, because if you just plot your graph, sometimes it might be too small and then you can't see it clearly. So I set it to 12:10, and now it's big enough for us to see. Okay, I'm moving on. This is where we're going to do the actual filling in of the missing values. In this case, in order to decide how to fill in our missing values, we're going to look at the distribution of the data. So first of all, when it comes to filling in missing values, the easiest way is to impute the values using either the mean or the mode. Imputing just means you're calculating the value of the mean or the mode, depending on what you've chosen, and you're filling in that missing value with the mean or the mode. Here you can see that we're going to first create a histograph. And each of the bars forms a sort of curved shape. Let me move on over to, here you go. Don't worry about the code, I'll get back to that in a minute. I wanted to show you what I'm talking about. The histogram will usually form a curved shape like this. All the bars will be underneath it. And you'll have three different types of what are known as skews. The shape formed by the curve shows you the skew. A positive skew will have a longer tail to the right-hand side. That's because this is where the positive values are on the number line. You all remember the number line, right, from school? The negative values will be this side and the positive values will be here. So if the tail is longer towards the positive values, it's called a positive skew. Likewise, if the tail is longer towards the left-hand side, that's called a negative skew. An ideal distribution is also called a symmetrical distribution, and it should give you a bell curve like this. This is called a bell curve. These are bell curves as well, the ones on the right and left, but they have longer tails, so they're not symmetrical. I'll move back to the code now. I hope all of you have the histogram plotted. I set the figure size to 20 by 20, but you have the freedom to set it as you like.
Yes, ma'am.
Okay. So I want to get a bit of participant interaction here. Can anyone tell me what curve the first graph indicates?
Can our participants answer the following question?
This first graph here, can anyone tell me what curve it's showing? Is it positive or negative? Okay, maybe interacting will be a little challenging.
Ma'am, I believe it's positive.
Okay, will they be able to speak to me or it's just the chat?
Ma'am, the audience will be able to access through the chat itself.
Ah, yes, I see somebody has responded. Thank you, Anaga. You said positive, and that's absolutely right. Because the tail is extending towards the right-hand side. For the rest of you who said the same, you're correct. So that means you've understood about positive and negative skews. Now I'll go back to my diagram, and I'm going to show you why these skews are important. As you can see, the mode, especially in a positive skew, will be to the left-hand side, and the median is, of course, at the middle, always. You can see it in the diagram as well. And the mean is to the right-hand side. So this helps us decide whether we want to use the mode or the mean to impute our values. Our objective is to get it symmetrical. So in the interest of time, I'm not going to go through each of the graphs, but I do encourage you to look at each of the graphs later on, probably once the session is over and you have the copy of the code. For now, let's start imputing the values. So we're going to use the fill any method. This is going to fill in the values for us. All we have to do is specify which column we want the values to be filled in and what value we want. In the case of glucose, we want the mean value. So just use dot mean. And when you say in place, this means that within the data frame that you're working with, you're replacing the values. In this case, we already created a copy, so it's okay to use in place. Usually, if you're working with your original data set, it's highly recommended that you don't use in place. Of course, that's a preference from data scientist to data scientist, but as students, I'm just giving you the best practices. So while you're typing, I'll just explain a little more. Now, when you're talking about a left skew or a negative skew, the mean will be to the left-hand side and the mode will be to the right-hand side. So accordingly, we can decide whether to impute with mean or mode. I'll assume that everybody has finished. Okay, so once again, I just plotted the histogram just to see the change once we've imputed the values. But in the interest of time, I encourage you to take a closer look later on. For now, we're going to move forward. Pair plots are another important EDA visualization. This helps us understand individual correlations. You could say that this is the equivalent of the heat map, but in the form of a dotted plot. Since we have 9 columns, we have quite a lot of plots here. To make it easier for you, I'll tell you that already I can see 3 interesting correlations. And now we're going to create individual plots for these correlations. So we're just going to create a function, and this is where Plotly comes into the picture. I thought this would be good practice for all of you. So in this function, we're going to take the outcome, and particularly, we're going to take the zeros and ones. Here you can see exclamation equal to, that indicates not equal to. So in other words, we're just saying the value should be 1. I'll try not to come in the way because all of you are typing. So I'll just move my cursor around. D will take the value of 1. H will take the value of 0. And then we're going to start plotting the actual scatter plot. On the x-axis, we're going to take D. And on the y-axis, we're going to take H. D feature 2. In other words, this feature 1 and feature 2 are the specific features that we're working with. And we're going to take 1 for each of them. The name of the plot is diabetic, and the mode is markers. We want markers in our plot. You'll understand when you see the actual plot. Opacity is absolutely optional. I just set it to 80. You can use any opacity value you like. And for the marker, once again, to stay within the theme, I decided to go with light sky blue, but you're free to use any color you like. And line here indicates the text, how large we would like it. I kept the width as 1 because it's visible without being too large. So that's our first plot. Then we have the next plot called trace 1. And here on the x-axis, we're using H, that is 0, for feature 1 and feature 2. This plot is going to be called healthy, so we're identifying the healthy people. And opacity, you know, mode, you know, marker, I just use the color indigo. But you can use anything you like. Next, we're going to set the layout. This just means we're going to set the title and a little bit of fine-tuning for the final graph. For the title, it'll display the name of feature 1, then leave a space. That's what this double quotation is for. We're just saying leave a space. Then versus, leave a space, feature 2. For y-axis, we want the title to be feature 2. And 0 line just indicates if you want 0 or not. I set it to false. You can set it to true. In fact, even after this workshop, I highly encourage you to experiment with the code. That's the best way to learn. Constantly experiment. Because data science is not an exact science. It is actually a lot of trial and error. I'll move on to the next section. This is where we indicate that our plots will be trace 0 and trace 1. Then for the figure, we say that the data should be plots and the layout should be layout, which we've defined here. This will populate the figure. And then we say pi.iplot figure. This is going to generate the actual graph. Since we defined it as a function, we're not going to get the graphs right away. We need to call the function. I'll move on to our first graph. So this one is plot feature 1, feature 2. That's the name of our function. And we're giving the features as pregnancies and age. That is the first interesting correlation that I found. And I decided to plot that separately. Even in future, as you move forward and work on data science projects, it is a good idea to isolate the most interesting correlations and features so that even non-technical viewers will understand. Okay, I'm glad to see. I just checked out the chat. I have to keep switching between tabs. So some of you have agreed that you will experiment. I'm glad. Okay, I think some of you wanted me to go back to this line of code here. I admit it is quite a lot to type. So I will give you a few more seconds to type it in.
And I believe we can move ahead.
Okay, so shall I continue? I hope at least most of you are ready. Because now I'm going to
Yes,
show
ma'am.
you. Okay, good. Now I'm going to show you how to understand your graph. Many times I find that beginners feel a little lost. That's true, right? There are just so many dots. What sense do you make out of it? So in this graph, we find that people between the ages of 35, that is rather less than 35, sorry, and with pregnancies less than 6. So that means if they were pregnant less than 6 times, then they are more likely to be affected by diabetes. So we can see that the age is here, and 35 is about the middle right here. And pregnancies less than 6 is what I said. So we should go to these 4 right here. You can see that most of the overlapping of the data points happens within this region. Don't worry, it does take practice. Many first-time data scientists struggle here, but if you keep practicing how to generate plots and understand them, then you'll soon get the hang of it. Basically, what you're looking for is the overlapping of data points. Now, in the second one, I want someone from the audience to tell me what you understand from the graph. It's okay, there are no right or wrong answers. I just want to make sure that I have explained clearly.
Participants can analyze the graph and answer in the comment section.
Remember, this graph is for glucose versus insulin. And we have considered only healthy people here. If you remember, we took the value of 0. Okay, I'm switching my tab. Oh, you probably need to see it. Okay, I'll leave it open for some more time. All you're looking for is the region where most of the data points are accumulated. That means there should be a lot of purple and light blue. In data science, it is very common to use approximate values because it's all about predicting and making assumptions. So most often we don't use exact values. But our objective is to get the best possible assumption or prediction. I'm looking at the chat again. Oh, I think there is a little bit of confusion. The idea was for you to open your own Colab notebook and type in as you see on my screen. There is no link to this notebook, but I will upload it later to GitHub.
I think our participants might have gotten lost somewhere. So, ma'am,
Okay.
as far as I have analyzed the graph, I guess answer should be between 80 to 100. Am I right?
That's a good approximation, yes. In fact, it is for glucose, the value would be greater than 100. All right. I know in this case, it might be a little difficult because the purple dots are darker and they're actually covering some of the light blue dots. So 80 to 100 is a very close estimation. That's a very good answer. And in the case of, oh, I myself got confused. So first of all, glucose I was talking about, 100, all right, this region here. And then insulin, the value greater than 180. So roughly around this region, right here, you can see all the accumulation happens here. And in our chat, somebody else has also mentioned healthy people have lower insulin. I think that's a little wrong because insulin helps with reducing diabetes. So, but no worries. I'm happy that you have participated and given your answer. The next graph, in the interest of time, I'm just going to tell you. We're looking at the skin thickness. If you remember, that's at the tricep, the skin fold. In medical terms, this is a very important feature. So one more handy tip for all of you. When you're working on a data science project, especially in places like medicine or anything else, it is important to have an expert in that field that you can collaborate with. Because many times you might know how to work with the data, but if you don't know anything about medicine, there's no use. So just keep that in mind. In this graph, we can see most of the accumulation happening here. Although the purple is more visible, there are light blue dots hidden underneath. All right, so all the values less than 30 for thickness and less than 45 for BMI. I can see that a lot of you have understood at least how to look at a graph, and I'm very happy. This is an important skill as you move on as a data scientist. Now, to prepare your data for the model, you need to standardize it. And that's what we're going to work on. There are many different scales, but we are going to work with the min-max scale. Because when I prepared this project for you, I found that min-max gave the highest possible accuracy. So kindly type in the code. Make sure to use diabetes data copy and specify the columns. So while you're typing, I'll just explain a little more. The reason we need to standardize or normalize, these are terms that you're going to hear in the data science world, standardizing, normalizing, and scaling. They all basically serve the same purpose. It's to make sure that the data can be properly calculated by the model. That is, the distance between the data points can be properly calculated by the model. It brings it within an easier range for the model to work with. Because if the data is too far apart and too varied, the model might have trouble giving you a good accuracy. I hope that was clear. And then just to make sure that the min-max scaling has worked properly, we're going to say x.head to get a look at the first 5 rows. In this case, x essentially becomes our variables or features that we're going to feed the model. Next, you can see that I've typed in y here, and I specified that only the outcome column should be present in it. Y becomes our target variable. This is the variable that we want our model to predict. So when we feed the model, we do not give the outcome column to the model because we want the model to predict that value. We use the outcome model to make sure that, the outcome column to make sure that the model has correctly predicted the output. So if that is done, then we have the test train split. We're not doing cross-validation just yet, so kindly ignore that. What we're doing is splitting our data. We're going to use the sklearn library because it has a nice function already for us called the train test split function. All we have to do is give the names of the train data and the test data. That is x_train and x_test. These will be our train and test datas respectively. And y_train, this is just the target variable for the training data, and y_test is the target variable for the test data. Then we apply the function on it. So we give x separately and y separately. And test size. Now, when you're splitting your data as train and test, always remember to keep the majority of the data for training. The more data you train your model on, the better the accuracy, and the more it can learn. Testing is just to identify if the model is predicting correctly or not, so you don't need too much data for it. A good rule of thumb is to split your data such that 20% or about 30% goes in the test set. Or you can represent it as a fraction. 1/3 of the data, in this case, is going to the test set, and the remaining will be the train set. Then you can see random state here. This is to ensure that the values are selected at random. This will reduce bias. Bias usually interferes with the accuracy of the model's prediction. So it's a good idea, a good practice to randomize the data splitting. And 42 here is what we call a seed value. This makes it reproducible so that if anyone else wants to use your notebook or to build the same model as you have, they'll get the same output. So I'm going to move forward. I'm assuming by now that most of you are just watching my screen, so that allows me to move forward quick. We're finally ready to start building the model. Our data is fully prepared, so now we're going to build the model. We're going to work with a simple deep neural network consisting of dense layers. As I told you, sequential means that each of the layers will be executed in order. And what you see here is the input shape. So that is, we're expecting 8 channels. Because if you remember, our data set has a total of 9 columns, but the 9th column is our target variable. So we have removed that, which means now 8 columns are left. That's why we say 8 here. And activation functions. Activation functions are important because they decide how this network is going to deal with the data. Within the neural network, there are weights which are generated, and this activation function works on those weights. So in the interest of time, I'm not going to get too much into detail because that will involve statistics. And I'm not sure, some of you might be really good at statistics. Some might be not too comfortable with statistics. So the simplest way I'm going to put it is there are weights which are generated, and the ReLU activation function will process those weights and decide which weights are to be kept and which ones are not so important. Then we have the input shape. This is just the shape of the columns. Then we have the next layer. I found that 3 layers gives us a pretty good accuracy. So I've worked with 3 layers, but later on I highly encourage you to increase the number of layers and see how your results change. Whether you can get an even better accuracy or if it somehow makes the accuracy worse by any chance. So Relu, I explained to you. By the second layer, we're expecting the output to reduce to at least half. So from 8 features, we're expecting that our model will find a minimum of 4 features that will be really important to predict the final output. So we just kept it at 4. As I said, data science is highly experimental. So you could always play around with the values and see what your output is. Now in the final one, since we have just 2 classes, that is diabetic or not diabetic, we require just a single input, or rather a single node, sorry. And this single node is going to take the features, and it is going to tell you once and for all if the patient is diabetic or not. In this case, we're using an activation function called sigmoid. Sigmoid is really good for binary classification. When you have just 2 classes, it is called binary classification. And with sigmoid, you need to remember it'll give you a value that lies between 0 and 1. So it could be 0.5 or 0.2. So although our final outcome column has only zeros or ones, sigmoid will give us values between 0 and 1. Don't worry, later on we're going to handle this so that we can properly compare the output of the model to the actual output. Once you build the model, you're not ready to run it yet. You need to do something called compiling the model. This just tells it what universal loss function and optimizer to use. Usually, people use Adam. That's a very common optimizer. But we're going to define a different optimizer, and that's called RMS prop. Since we use the min-max scale, RMS prop is the best choice. And we're going to say the loss function, is binary cross entropy. Like I told you, we're doing binary classification. So binary cross entropy is ideal. And then we have the metrics, that's accuracy. We just want to look at the accuracy for now. So as the model is training, it's going to print out the accuracy at each epoch. Then we can take a look at the summary of our model. It's just going to show us that the model is sequential. And we have dense layers, where the first one will accept 8 inputs, and the next will accept about 4, and the final one takes 1. So this is just giving you the rough number of parameters that will be generated by the model. Now that you've compiled your model, you're finally ready to train. So for those of you who are typing, this part will take time. Okay, let me explain it. The good thing is, since we're using GPUs here, it should take just about 5 to 10 minutes to train, ideally even less. If you were running it on your local system, it would take more time. So first we set the epochs. I set it to 1000. You can feel free to play around with this. I find that with 1000, I get a really good accuracy. But if you train it even longer, then who knows, your accuracy could increase. So we use the function model.fit to train the actual model. And we give it the data, where we say X is the features and Y is the target variable. Then we say epochs is equal to epochs, which was defined separately here. Another way to write it is to directly feed the value here. So you can just say epochs is equal to 1000. And verbals, we're setting it to 2. This is just to indicate that we want updates to be printed at each epoch. You can see here in my notebook that for the first epoch, it has shown us the loss and the accuracy. So likewise, it keeps training for a total of 1,000 epochs. And you can see that it's 1,000 is a lot, so okay, maybe no need of showing you the end. So at the end, instead of going through the entire cell, I just calculated the accuracy using model.evaluate, and I gave it x, y, and then I said just print the accuracy in the form of a percentage. Model.evaluate processes the model and gives you the final accuracy. In this case, I was able to get an accuracy of 84.24. But like I said, if you increase the number of epochs, you could even get a higher accuracy. For the purpose of our project right now, 84 is good. So once you have evaluated your model, you need to check something known as true positives, true negatives, false positives, and false negatives. I'll explain the importance to you. So first, here you go. As I was telling you, to evaluate the performance of our model, we generate what is known as a confusion matrix, which has true positives, false positives, and then false negatives and true negatives. Okay? Even when you look at the graph, you will know which one is a true positive or a true negative, and so on. A true positive is, in this case, we're saying that 0 is a positive value because it means that the patient does not have diabetes. So when you're here, it is 0 and 0. I hope this is visible to all of you. So that makes it a true positive. But when you're at this point, it is 0 and 1. So this is a false positive. And especially in medicine, a false positive and a true positive, or a false negative and a true negative, are very important. Think of it this way. A true negative means you're telling your patient that they don't have diabetes. But the truth is, they do have diabetes. So don't you think that's dangerous? They'll be thinking that they are healthy, they are fine, they won't take care, and they don't get the medication that they need. That's so dangerous. So this is why it is important to check the true positives, false negatives, and true negatives. Now I'll show you the code. In the library sklearn, we have a function, or rather a module, called confusion matrix. This generates the matrix for us. So we first get the prediction from the model using .predict. So we pass x_test. This means that the model is going to run through the test data and give us predictions for each of them. Now, if you remember, I told you that we used sigmoid as our activation function. So currently, our prediction values lie within the range of 0 to 1, which means we can't properly compare the outcome variable, that is the target variable, with our model's predictions. So to bring it to values of only 0 or 1, we're going to round them off using the around function. So we pass our predictions to this around function, and that's how we get the values between exactly as 0 or 1. At this point, it is going to be exactly 0 or 1. Now we can use the confusion matrix method, and we're going to pass the values of the actual outcome that is expected. So that's y_test and our prediction. Remember, in this case, it is the rounded off version of the prediction. Then, to make it easier to visualize, we're going to generate a heat map. just like we did before. We set the annotation. This way we know the exact values. And the CMAP. FMT is just for the text. Then we'll set the title and the label names. So this is the final confusion matrix. Once you're happy with your model, the last step is to save it. In TensorFlow, it's very easy. All you have to do is type in the name of the model, in this case it's model, and say .save. Then you can give a name to the file. In the GitHub repo, under the test folder, maybe let me show it to you. I've saved a copy of the model. Oh, it is not in this one. It is in the original one. Here you go. This is the link that I've given to all of you, and you will have a test folder here. This is the one, diabetes.h5. This is important for the Streamlit app. Okay, it got really quiet, so I would like to check on the, I'm just checking the chat to make sure everybody is with me still. Okay, I'm seeing good feedback. Thank you, everyone. I'm glad you're all learning. I wonder if you guys would like a little break or something, because we're going to move on to the next step, which is the Streamlit app. Admins?
Hi, ma'am.
Hello.
I think we can take a short break.
Okay.
We'll get back to them in 5 minutes. And is that okay for you?
Yes, that's perfectly fine.
Ma'am, till that time, you can present the code part so that they can get on with it.
Okay, sure. So when it comes to Streamlit, you need to, oh, sorry, were you saying something?
No, ma'am. No.
Okay. When it comes to Streamlit, we need to use a Python file. So you're no longer going to use your notebook. You're now going to just open a text file. And later on, when you save the file, you can add the extension .py. That's py. Let me increase it. I hope it's clear.
Ma'am, we cannot see your screen.
Oh, maybe the sharing has
You
stopped.
didn't press. Yeah.
Is my screen visible now? Hopefully it's visible.
Yes, ma'am.
Yes.
Okay. So this is the code.
Till that time, if participants have any doubt, they can ask in the private chat. They can ask in the comment section. Thank you, Bridget sir.
Thank you, audience. We're liking the reactions here.
Okay, so I'm back, and I was just taking a look at all of your comments. Thank you for all the positive feedback. I did notice that somebody has asked a question. Swappy Stark, you asked if there are other examples of classification models. That's a very good question. In the case of neural networks, um, there aren't explicitly any classification networks and such. You just build your neural network, and depending on how you use it, it will become a classification model or a regression model, and so on. So you could use an RNN, that's a recurrent neural network, or you could use a convolutional neural network. So these are examples of neural networks, and then it depends on how you're using it. That's the good thing with neural networks. It learns on its own. You don't have to explicitly tell it that I want you to classify or I want you to do regression. All you do is feed it the data, and it knows what to do. So for the Streamlit app, I just kept a little virtual environment ready for all of you because I want you to see how the app looks. You should be seeing my screen right now on this environment.
Yes, ma'am.
Okay. Cool. I'm going to start Streamlit. And the name of my file is, first you have to say run. And then the name of my file is app.py. So it's starting up the file. This is the app that I prepared for you. Now you can see a little error here. This is actually just a runtime error because I haven't uploaded any files yet. So it's telling me that it doesn't have a data frame to work with. Once I upload the file, this error will go away. So I just thought I'll explain the layout a little. In this app, we have the left-hand side, which is just a little sidebar. And it gives, let's say, if the user is a doctor. So the doctor has the option of just selecting a patient number. And it'll show the patient name below. I'll be demoing it in a little while. And on the right-hand side, you have the main window. This is where we allow the doctor to upload a record of patient names along with their details. The details are the same as the features that we just worked with. So Streamlit has an inbuilt file uploader. As soon as you say upload file, there we go. We're going to use patient_records as the data. We say open, and as I told you, that error has gone because now I have uploaded a file. With this file ready, I'm going to say predict. Oh, 1 second. It hasn't read the file properly. The good thing about Streamlit is, as you're changing your source code, you can see the changes in the app itself. So this is a good time to demo that as well. Let's see what's causing the issue. Ideally, it should work. Sometimes, since Streamlit is new, it does cause trouble.
I would like to inform you guys, after the end of this session, we'll be circulating a form where you can submit your project after the session, whatever you have learned from the session, and we can later review it, and you can share your GitHub repository with us. You'll get points with that, and as you know, we follow a goodie system, so accordingly you will be rewarded. I hope you guys are excited for that.
Okay, so as I said, sometimes, oh, sorry, there's someone talking.
No, ma'am, you can
No,
continue.
ma'am.
Okay, so sometimes Streamlit might cause trouble when it comes to reading in files, especially if you have uploaded them. So what I did is I moved over to the next patient. As I told you, a doctor can select patients on this side, the left-hand side. Remember that in Python, the count starts from 0. So although I say patient 0, it's going to show me the name as patient 1. And then if I choose patient number 1, it shows me that the name of the patient is patient 2. And now I'll show you how the predict button works. It ran through the model, all the data of patient number 2, and we identified that patient 2 does not have diabetes. So we give a little notification here that the patient does not have diabetes. This is how your app will look, and this is how a user can interact with the app. So the file will be shared with you, probably after this session. I hope all of you understood how it works and you like the interface. The good thing about Streamlit is that you have a lot of options to change it as you like. You could even turn this into a drop-down menu instead of just patient numbers. Or you could switch the location of the file uploader. You could put it in the side bar. That's the good thing about Streamlit. So now, perhaps I'll run through the code with all of you, because you need to understand what the code does. Let's just increase that. Okay. When it comes to Streamlit, the first step you need to do is load all the libraries and make sure that these libraries are present on your local system. Then as you make changes within the file, it'll show up in your actual Streamlit window. After importing the files, I decided to add a heading. So I used st.markdown. Markdown allows me to stylize the text however I like. In this case, I wanted to add a bold heading. That's heading 1. So I used H1 and I said align in the center, and I gave the name of the heading. Unsafe allow HTML. This just ensures that there are no conflicts with the port where your Streamlit app is visible, because sometimes it might say that the URL is unsafe and so it's not going to display properly. So this helps us ignore those kind of errors. This is all in the background, so you don't have to worry too much about it. Then next I put the second heading, which is Epsilon 2021. And I wanted that to be in the style of heading 3. So that's what I did. You could add more text if you want, or you could remove some of the headings. You have that freedom. Now this is important. I wanted to show you about the cache. The thing with Streamlit is each time you run it, it considers that run as a fresh start. So it does not store any data. It does not remember any actions that you have done previously, which could be a problem, especially in this case, because in this app, I want my user to be able to switch between patient numbers without having to upload the file each time. So when I use cache, you can see that I change the number and the file remains here. That means the app has remembered the file and stored it. If I don't use cache, then each time after changing the number, the person has to keep uploading the file. So now that that's clear, allow output mutation. This is again to avoid any conflicts with the output. Sometimes if there's a minor difference in the encoding or something like that, it can cause problems, especially since we'll be uploading a CSV file. So I just set it to true. This way it's going to ignore those minor issues. And because of that, I was able to successfully, let me just go back to the app. I was able to successfully upload the CSV file. And then we have the function, which actually uploads the file. This is another important point. With the current version of Streamlit, I find that if you want to use the cache, then you need to upload your document within a function. If you try to do it outside a function, it causes errors. So that's a little tip for you to remember. Perhaps in the future, as Streamlit improves, this may not be an issue. So we used pandas to read in the CSV. and store it as a data frame. Next, we used st.fileUploader. This is Streamlit's inbuilt function to allow external users to upload their own files directly from their local system, just as you saw me uploading the patient records file. And this is a little exception we add here, saying that only if the user has selected a file, then we upload the file. This is to avoid any errors. After that, this is where we create the sidebar in the app, this sidebar here. So we say st.sidebar and we put a title so that the user knows what is going on within that sidebar. For the counter, we need to set a variable. So I set it as A. And then we say sidebar.number_input. This is the inbuilt function which allows the user to enter a number. Now they can enter it manually. So I can click here and say probably 9 and hit enter. Then I get patient number 10, which is the name of the patient. Or the user can use the plus and minus. Next, to display the name of the patient, I created the variable name and said the location of the variable should be displayed. Since A is the number selected by the user, we're going to get whatever value is present at the number A. So if the person has selected 1, then you will get 1, 0. It's important to say 0 because we're saying the column should be the very first column. Only then will it display just the name. And then to print the name so that we can see it, to see the name, I've used st.sidebar.write. And then I said, just write the name. That's it. Now, for the sake of our model, I dropped the name column because name is a string and our model can work only with numeric values. So it can work with integers or floats, but it cannot work with strings. So we just drop that column. And then, just as we did in our notebook, we need to apply min-max scaling. We apply it on the columns just as we did previously. So we apply it on the column pregnancies, glucose, blood pressure, and so on. Now this is another important thing. You remember that we saved our model, but if you want it to be used in this app, you need to load the model. To do this, we create the variable model, and we say that's equal to tf.keras.models.load_model. This function is going to read in the .h5 file that we saved earlier. So within single quotations, just type in the name of your file. And before that, one more important thing you should know is that you should store the diabetes.h5 file, or whichever model file you're working with, in the home directory, wherever Streamlit has been installed. In my case, it is installed under home_rime. So I've put my app file there as well so that it can run smoothly. And the diabetes.h5 file is present there as well. The patient records, I just put it in the home for convenience sake, but it can really be anywhere, because anyway, the user has to upload it. Okay, so I hope all that is clear. These are all important factors to keep in mind when you are working with Streamlit on your local system. Then Streamlit gives us the option of creating buttons. So as you saw here, I created a button for prediction. This ensures that only when the user presses the predict button, the model runs on the data and gives the output for the specific patient. If you don't put the button, Streamlit will automatically run the code such that the model will just run on the data and it will give you all the outputs. So first I created the button saying submit is equal to st.button. And within quotations, this is the text that will appear on the button itself. You can make it as long or as short as you like. It's up to you. Then I put an if loop. This will create the functionality for the button, because at this point, all you have is a button, but it will not work. Now, once you create the if loop, it'll actually give you some sort of output. In this case, I say that once the button is pressed, the predict button, then the model should give me predictions, and those predictions should be rounded off, but the final display should be only for the patient number that I have selected, which is A. Then I put an additional if loop. Keep in mind, when you have two if loops like this, it is called nested if loops. That means the second one is nested, or it runs within the first if loop. So in my second if loop, I'm saying if prediction is equal to 0, then I want the display to be congratulations, the patient is not diabetic. Now you'll notice st.success here. Streamlit offers an inbuilt function so that it displays the message in a colored window. As you saw, it gave us a green, like this, a green box. This just helps to draw the user's attention to the text. Because if it's plain text, then it doesn't look good, right? You want the user interface to look nice. And if the value is 1, that's what else indicates here. Else means that any value other than 0 should give you, sorry, patient is diabetic. And in this case, we have only the options 0 and 1. So the other value is obviously going to be 1. Okay, so that is your code for the Streamlit app. Next, we have deployment. So I wonder if you have your cloud ready. So far, I think you're just watching the demo. So I'm going to check the chat now, just in case anybody has any other doubts. Okay, looks good. So the next part is deployment. Should we take a break again or continue?
We can give them a 5-minute break, I think.
Okay.
If our audiences have any doubts or queries what have ma'am taught us till now, you can post it in the chat box.
If you have any questions regarding the project you're going to submit, you can ask the questions too. You guys have a chance to show your skills, whatever you have learned today or whatever you have learned already by yourself. You can create great projects like ma'am have told us. You can create similar projects or and you can just submit us and we'll circulate the link after the session. You can use the same platform, Streamlit, GitHub. It is your call and you know the badge system. You are assigned points for everything you do. So just make sure that your projects are top notch.
Yes, you guys can select your own machine learning problem or build the same that ma'am has taught us and deploy the model using the Streamlit framework as well. And you can have your model pushed onto the GitHub repository, whose link you need to provide in the form that we'll be sharing after the stream. And make sure you submit your projects before 11:59 p.m. today. And if you haven't joined the Discord server, please register fast, wherein all the description along with the prerequisites are mentioned.
Ma'am, there is a question from
Yes.
Samiksha. She's asking if there are any other methods to deploy models other than Docker.
Yes, that's a good question. You have Heroku. So directly you can deploy with Heroku. The good thing about Docker is you can create your image, which is a container. So this isolates your app with all the requirements for that app into a single container. And then that container you can deploy on any cloud platform, whether it's Google or Amazon. It just makes it a lot easier. In case some of you are worried if Docker is not working, then what we're doing here is we're just creating the Docker file. And lucky for us, Google directly deploys it. So you don't really need to work in the Docker CLI. So don't worry too much about that.
There is another question from Aryan. He's asking what is the main use of discriminant analysis?
So this is specifically good for categorical variables because the model is going to discriminate between these variables. You could say, in fact, that our current problem right here, there are two classes, right? Those can also be called as categories in the form of integers. We have the patients who are diabetic and the patients who are not diabetic. So discriminant analysis will help us identify which patients have diabetes and which patients don't have diabetes. Similarly, you could talk about patients who maybe have leukemia or any other disease. I hope that answers your question.
Yes, ma'am. Another
And we have,
question from Samisha.
what's the main algorithm behind churn prediction?
Oh, there is no single algorithm. There are, in fact, multiple algorithms. Because in churn prediction, you're just trying to identify, correct, like which customers are most likely to return to you for your product or your solution. So that's going to be a very long answer if we really get into it. So just remember, there is no single algorithm. So I hope that answers your question. Oh,
Now
I
we
see
have,
one more.
we have another question by Tisha. Does naive bias falls under any of the classifications model?
No, not specifically classification. You can, like naive Bayes is actually a statistical method. So you could have logistic regression under it, or classification, or even clustering. There are multiple different types. That will come under advanced statistics.
I think, ma'am, we can go back for the deploy.
Okay, sounds good. So, right, my screen, let me just share it again. Okay, it should be visible now. Okay, looks like it's visible. So now we're going to talk about deployment. And as you would have seen, I requested Google Cloud. This is because Google Cloud does not start billing or, basically billing. It does not start taking your money right away. It gives you a free trial, and then only if you choose to upgrade, it starts billing you. I find that this is a good option for students because otherwise, if you use Amazon, it's going to start billing you right away. So let's start with the files that we need for deploying our app. As I told you, we want to create a container which contains everything that is required for our app. So this means from the data to the libraries and, of course, languages. So in this case, Python. Everything needs to be in that one container. That's why I gave this template here. In this repo, we have the data and then the Docker file. So I gave a blank one for all of you because I thought that you could fill it in as I show it to you. So for those of you who are currently typing and following along, kindly open the Docker file and then edit it. In the Docker file, first of all, you need to type in from. This indicates which existing image you want to use as the base of your app. So since our app is Python, it uses Python, we're going to take a Python image directly from Docker. So just type in from and then Python. You can choose any version. Don't worry too much about whether it's slim or not. That's just extra functionality. You can just go with the standard one. Next, you need to expose the port. This means you're setting up the port where you want your app to be displayed. Now, you could choose any port, but there's a lot of extra background work which goes into that. For beginners, the recommended port is 8080 because this is generally always free. Sometimes you might have security issues if you try other ports, so you really need to check which port is free and which one is not. So for now, just stick to 8080. Next, you're going to install pip. So use the run command and say pip. We're using pip because all of our libraries are Python libraries. So pip is just going to make our life easier by installing the packages for us. After that, we're going to create a copy of the requirements.txt. So I will show you what the requirements.txt is in the next step. So for now, just make a copy of it. And then we want it to automatically run so that all the requirements are installed. So we're going to use the run command. And using pip, we're going to install all of the requirements. Next, we have, this is just an additional step, which is not mandatory, but it's a good practice. Try to create a copy of the app file so that you have one copy of the original and one which is a copy that you can work with. So use the copy command and say app, then change your working directory to the app. Finally, you're ready to run the actual app. So we're going to specify that this is a Streamlit app, and we're going to run the run command. So that's what this is for. And the file is app.py. So if you name your file anything else, make sure that you also change the name here. Then, as I told you, we are going to use the port 8080. And the address, it's good practice to use 000. This just means in the URL, the address will be 000. So I'll move on to the next file. I'm assuming that all of you have this ready. The next file that you need to keep is known as the make file, especially for our current project. Since we are working with Google App Engine, .phony just indicates that we're creating a dummy container. This is just to make sure that the app runs smoothly by having one dummy container with the original one. So we say run, and then gcloud deploy. This is the command to actually deploy the app. So under run, we say Streamlit, run. As you saw me typing in the Streamlit demo, I said Streamlit run, and then I gave the name of the app. So here we're going to do the same, but we're going to specify that the server port should be 8080 and the address should be 0. Then we're going to run the container. We can leave it as app name because later on it gets automatically filled in with our app's name. After building, we run the app. So it'll be visible at port 8080. That's what the -p flag is for, 8080. And then gcloud deploy. This is where the app gets deployed using the app.yaml file, which I will show you later on. Okay, so I will move to the next file. The next file is the app.py file, which is the Streamlit app, which I just showed you. All you have to do is upload it. So I'm not going to go through the code again because I already explained it. And now the app.yml. This is just the requirements so that the app can run, where we say runtime is custom. That means we want to specify how it should run. And the environment is Flex. There are many different options for environment. Flex is the standard one. So we're just going with Flex. You could use Ubuntu or Windows or anything. It's really up to you. Now we have the requirements text. I'm sure you've been wondering what that is. It's a really simple document. You just name the libraries that you want to be installed in your Docker image. So we require Streamlit, Pandas, TensorFlow, Keras, NumPy. Oh, I've written Pandas twice. It's okay even if you duplicate the name, that's no problem. But ideally, just write it once. And ML extend, that is for the min-max scaling. So once you have all these files, you're ready to start deployment. For the deployment, I'm assuming that you've already downloaded your Google SDK. All of that setup is separate. Let me just open a new terminal. Okay, the first thing you're going to do is clone the GitHub repository. So you're going to say git clone and give the HTTPS link. Copy that and paste it. So this is what it should look like. I hope it is visible. Let me just, okay. Once it's done, it should show you 100% done, and you should be able to find it in your downloads. This is the one. In my case, this is the copy. So on yours, you should see IEEE Epsilon 2021 master. Make sure to unzip it. And in my case, I kept it in the downloads folder, but you can change the place. Just remember to use the correct file path. Wherever you extract the file, use the correct file path. So I'm going to work with downloads. Okay, once you cloned it, like I said, I'm assuming that you've already downloaded the Google SDK. So you need to enter the folder where you downloaded the Google SDK. In my case, it is in downloads. If I enter downloads, and now that I've entered downloads, I'm ready to use the Google SDK. But before I can use the Google SDK, I need to create a new project. So I'm going to go to my dashboard, and this is a test project that I created. But to show you the process, this is how it is. You click the arrow to the left-hand side at the top, and you say New Project. Then you just give a name to the project. I'm going to say test 1, and location is not too important. So setting up the project shouldn't take too long. Might take a few minutes depending on your Wi-Fi, etc. Okay, mine is ready. Now it's important to keep track of the project ID. So for test 1, it automatically created a project ID for me called Ardent Strength, and then a certain set of numbers. Okay, now you have your project ready and set up, and you have your Google SDK.
So I hope you guys are working on your projects. If you have any questions, we can have a Q&A session. You can post your doubts or questions in the live chat box.
Yes, I hope you have completed and followed ma'am throughout the session and your projects are ready to deploy as well. If not, it's no issue. You can watch this video again and you have time till today. So, our speaker will be back in some time, so please wait. And after deployment, we can have a Q&A session.
Make sure you submit the form before 11:59 p.m. today so that rewarded.
Give it your best shot so you can win your badges and exciting goodies as well and be on the top of the leaderboard.
You guys can check our Instagram for the leaderboard. Make sure you get yourself on the top position.
Yes, we have the leaderboard on Instagram every day, so check it out.
Let's just have a great competition throughout Epsilon because we have many surprises for you. And also on 12 today now at 12:30 we have another session for cloud computing. So make sure you guys join there too.
Today the whole day is been dedicated to workshops, so please follow them and gain practical knowledge.
So here we have Anirudh Iyer on the top of the leaderboard. I want you guys to get on the top of the leaderboard. Let's just have a nice competition. It will be great. Our top 10 competitors will get amazing surprises. So
So our
let's get
speaker is
back
back with
to our
us. Yeah.
project.
Okay, everyone, sorry
Yes,
about that. I just had to drink some water. Okay, so this was the terminal. Right. Once you have your GitHub repository cloned and ready, and you have your SDK ready, all you have to do is initialize the SDK, all right, using Google Cloud SDK bin. This is just to make sure that you have it set up. For those of you who already set it up, you probably don't need to see this, but I want to make sure that for any of you who have trouble with it, you can see how it works. So I selected the project. So it's just letting me know which account I want to use. And now it's letting me select the project that I want. So I'm going to go with the new one. Good. So on my screen, it now tells me that the new project that I created is my current project. Okay. Let me probably, okay. I just cleared up the screen so that there are no distractions. Now's the fun part. We're ready to set up the project and deploy our file. Okay. Google Cloud is a little different from Amazon, so I keep thinking of the Amazon commands. Just a second. There we go. Right, so as I was saying, we're ready to deploy, and the command for that is gcloud deploy. Let's see, it needs to be initialized. So it asked me to initialize twice now. Maybe it didn't register the first time. Oh, the directory. Okay. So as you can see, it's very important to enter the correct directory. I didn't notice that it had come out, so I went back to downloads. Now if I use GC Cloud, nope. Okay, under downloads, you need to head over to the file, which is the GitHub repo that you just downloaded. So I'm going to copy that. Here, and I'm going to say, enter that. Good, as you can see, I've entered the GitHub repo. Okay, maybe the new project that I created is causing trouble. So I will go back to one of my existing projects. next time I'll try working with one of the existing projects. Hmm.
I hope uh, I hope you guys have deploying your project. If you have any doubts, you can ask.
So sorry about that, everyone. Yesterday when testing, it was working fine. Sometimes this happens.
It's all right, ma'am. We can understand.
Yeah, thanks. So I hope you enjoyed what I've done so far. And if you have any doubts there, please feel free to ask me. I'll share a file with the written instructions. The deployment part itself is easy. It's just the setup which takes time.
Ma'am, you
And if
can
you're
send us
wondering,
the
sorry,
written. I'm sorry. No, I was just saying you can send us the written instructions. We'll share it with everyone.
okay, I'll put it in the GitHub repo. In fact, I'll put a copy of the notebook and the Streamlit app, all of that.
Yes, ma'am.
Sure, ma'am.
Okay, you're welcome. In case you were wondering what your final app will look like, it'll look just like the Streamlit demo that I showed you. It'll look just like that. Oh, I see that one of you said thank you. You're very welcome. I'm sorry that the final deployment didn't work out.
It's all right, ma'am. I'm pretty sure the instructions you will give,
Yes,
audiences will follow them. Yeah.
it's super easy once you have it set up.
Thank you so much, ma'am, for such a captivating workshop. And I'm confident that our audience here have definitely learned something new and hopefully understood the concepts as well.
Mhm.
We think that we have discussed all our audience's doubts and questions and have come to an end of this amazing session. We would like to thank Ms. Vinita for joining us today and helping our participants to get through this workshop on diabetes classification. Thank you so much, ma'am, for spending your precious time with us and being part of this Epsilon 2021.
You're welcome. It was a pleasure being here.
Also, I would like to remind our participants about the project. The deadline is 11:59 p.m. today. Make sure you grab your place at the top of the leaderboard. We'll get back to you with an amazing session in cloud computing. So here is the point system we were talking about. Workshop is very important. It will give you 50 points and a great position at the leaderboard. So make sure you submit it on time. Here are our top 10 participants. I'd like to congratulate them on behalf of IEEE SIESGST.
We'd like to wish all the luck for the upcoming ventures and hope to see you again in future. We'd like to thank all the participants present here for being such an interactive audience and hope to see you all again tomorrow for day 3 of Epsilon 2021.
A wonderful scholastic panel will be waiting for you. It will be so enthralling. It will be so great. So I hope that you'll be there tomorrow with us. Until next time, this is your host, Shruti Singh.
And this is Shruti Tiwari signing off for today. See you tomorrow. And
See
don't
you
forget
guys.
to attend the next session for cloud computing.
Thank you guys for joining us.